Okay, solving inequalities where we've got a quadratic, the only way we can do this efficiently and making sure we get it right every single time is by graphing the question. Because if I have a parabola that sits like this, and it says where is the parabola greater than 0, it's anywhere above the line, so I can read it off the graph. If it's saying where is the parabola less than 0, again, it's anywhere below the line, so I can read it off the graph. So I'll do 3 examples of that. You need your factorising skills to be able to do these. Let's go this. Okay, x squared minus 5 is greater than or equal to 0. So I want to get it greater than or equal to 0 because then I can apply above the line and below the line. This is x minus root 5, x plus root 5, because it's the difference of 2 squareds is greater than or equal to 0. So I want to draw it. It cuts at minus root 5 and plus root 5. And the question says, where is the parabola bigger than or equal to 0? So bigger than or equal to 0 is above the line. So I can say it's here and it's here. How do I write that? I say x is less than or equal to minus root 5 and x is greater than or equal to root 5. Because it's what we call non-continuous, so there's a gap, we have to write these as 2 separate. Hopefully here I'll find one where it's continuous. Let's have a look at this question. They've already made it equal to 0 or greater than or less than 0, so I don't have to do this first step. I just need to factorise what 2 numbers times together to give me minus 2 and add together to give me minus 3. I'm going to change the question because I would have to, I don't think that one's actually, I think it's a bit of a typo there. So we'll just change the question so it does work. Minus 3 minus 2, x minus 2, x minus 1 is the factorisation, is less than 0. Draw it. It cuts at 2 and at 1, and it's happy. It says, where is the graph less than 0? And we can easily see that the graph is less than 0 here. And it's nice because that one's continuous, so I can write that it's greater than 1 and less than 2. Because it's continuous, I can write it as a group like that. Let's have a look at this one. I'm going to bring the 4x squared over because I want to be able to draw a happy parabola. I don't want to draw an upside down parabola because then it's just easier if I keep consistent with these diagrams. So I've got 4x squared plus 22x is greater than or equal to 0. Now I'm going to factorise by taking 2x out the front. X plus 11 is greater than or equal to 0. So that means I've got a parabola that intercepts at 0 from here, intercepts at minus 11 from here, and goes like that. And I want to know where is the parabola bigger than 0. It's when it's less than or equal to minus 11, which is this part, and when x is greater or equal to 0, which is this part. So there are 3 great examples there to see how we solve a quadratic inequality. It says sketch the graph clearly showing the x-intercept, which we did. When the graph is above the x-intercept, it's greater than, or where it's below, it's less than. So when you're doing your notes, to look back on how we did this is going to help you more than that sentence, but it's there to remind you.